Hi everyone, this is Mr. West. We're going to be doing a Khan Academy tutorial today on recursive formulas for arithmetic sequences. This often gives a lot of students trouble, so let's go ahead and break this down into some more manageable pieces. Complete the recursive formula of the arithmetic sequence 12, 10, 8. Okay, so I think you get the pattern. This is all about patterns with sequences. Sequence is a pattern of numbers. So we have 12, 10, 8, 6, 4, 2, okay? And then it keeps going, 0, -2. It goes on forever. That's the part of a sequence. It just continues indefinitely, all right? Now, this recursive part, in terms of the formula, is what trips people up. It's got this weird notation. So in terms of the sequence, it has this number. Sorry, I wrote a letter. It has this letter, and then this represents the end, that's supposed to be a highlighter, represents a number in the sequence, okay? So that is the sequence number, okay? So what do I mean by that? Well, back in this first example, we have 12, 10, 8, 6. You can't see what I'm pointing at, so let me go ahead and write. This would be number 1. This would be number 2. That's the second number in the sequence. 8 would be the third. 6 would be the fourth, and then fifth, and then so on, okay? So we can number each term in the sequence. So sequence, I should write term number, okay? That's what it's all about. This B is just referring to this particular sequence, whatever it may be, all right? And then, so if we're looking at this first example, it says B1. What is that asking? It's about asking for the, man, I'm getting these pens all mixed up. It's asking for the first, that's where the 1 is, term, okay? So that's how we read that, okay? And this is for any number, any term, okay? And then the confusing part for most students, even for me when I was learning this, n-1, what is that talking about? That's talking about the previous term, okay? The term before, okay? Recursive means going back on itself, so you need the term before, okay? Whatever term you're thinking about, you need the previous term to input into a machine. So if this is a machine, this is the recursive formula, okay? It's like a machine where you have your input, which is the previous term, okay? You need that to go in. Something happens with the recursive formula, and what's outputted is the next term in the sequence, okay? So you need this previous term in order to determine the next term. Okay, so the first term it's asking about, according to this sequence right here, is clearly 12. So we know that the first term is 12, okay? Because it's the first one that we see in the order. All right. Now, when it's asking for this part, it's saying for any term, okay? For any term, what's the pattern? Okay, what are we doing? Well, we have to take the previous term and do something with it. So if we're looking here and we notice the top, we see 12, 10, 8. What are we doing to 12 to get to the next term? Okay, we take 12, we do something to it, and we get 10. What do? We subtract 2. Then to get the third term, how do we get the third term? We take 10, we do something to it, and we get 8. What do? We subtract 2. So the pattern is each time, and that's what this box is always for arithmetic, that means adding or subtracting, we're adding something each time. In this case, it's -2. We're adding a -2 each time. Okay, so first term, 12. What are we doing each time to the previous term to get to the next term? We're subtracting 2, and we can check our answer. Bada bing, bada boom. Next question. Here we go again. Okay, this is another sequence. This sequence is D, okay? So just a label, doesn't matter, just show that it's different. But again, it's asking for the first term. Well, the first term's always just the first one listed. Usually it gives it to you. So we can say our first term is 8. So we're gonna put, boom, 8. Now, it's asking, okay, the sequence, remember we do something to the previous, I thought that was a highlighter. We do something to the previous term. So if we take 8, what do we do to 8 to get to -5? Okay, how do we go from 8 to -5? We subtract, what is that, 13? From the previous term to get to the next term. And that's the same thing each time. These arithmetic sequences, we're going to be subtracting or adding the same thing each time. So in this case, we can add a -13, and that will help us get to the next term. Okay, that is the pattern. Okay, nice work, it says. Thank you for that affirmation, Khan Academy. Recursive formula. Number 3, 20, 26, 32, 38. What's the first term? I hope we can see that now. First term is 20. What are we adding each time to the previous term? Again, this represents the previous term. And I should have broke this down a little bit more. A to the n minus 1, okay? And this says a to the n. So let's just say, for example, let me label it 1, 2, 3. Let's say, for example, I wanted to know what the third term was, okay? I plug in the 3 here. This n and this n need a match. I plug in the 3, but then I need to subtract 1 to it, okay? So don't forget my plus blank, okay? So my third term will be the second term. 3 minus 1 is 2, okay? Notice how those match. 3 minus 1, 2. I need to take my second term and then add something to it. So if I look up here to my second term, it's 26. What do I add to 26 to get to my third term? Well, I know my third term is 32, and I have to do 26 plus whatever that box is. That so happens to be 6. Okay, so I'm adding 6 each time, and that's my pattern. I go plus 6 from the previous term to get the next term, plus 6 from the previous term to get the next term. And that's how it works. That's a way to understand what that n minus 1 means. It's just talking about the previous term to whatever one you're talking about. Okay, so now that we got that, we know this is going to be -1. That's the first term. And we look here, and we are subtracting 12 each time, not 2, 12. And boom, we got it. Great work. And you're going to get this screen after you've completed it. I hope this cleared some things up for you for arithmetic sequences and recursive formulas. I appreciate you watching. I look forward to seeing you next time right here on West Explains Best.